Okay, the last section that we need to talk about in this unit are cube roots. So title your notes, cube roots. Okay, so we're going to take a look at how to find the cube root of rational numbers, solving equations involving cubed numbers. All right, a lot of information here. You definitely want to get all of this. This video is not very long, so it's definitely is important that you get all of the vocabulary copied down here. This is our only word. Perfect cube. So in words, a perfect cube is the product of a rational number 3 times by itself. Okay, or we could say multiplied. That's multiplied 3 times by itself. The symbols. If x times x times x equals x to the third power, then x to the third power is a perfect cube. And if we look at that with actual numbers, 3 times 3 times 3 equals 27. So 27 is a perfect cube. If we take a look at our picture here, I have a cube with a height of 3, a base of 3, and a width of 3. You can see my three squares here, there, and there. Okay. Now if we were to look at the volume, so for cubing, we look at the volume. If I looked at the volume and actually counted these squares, I would end up with 27 squares. And the way we find that is the base times the width multiplied times the height. So all 3 of these numbers multiplied by each other gets us our volume of 27. Now this radical symbol, when we're looking to cube or find the cube root, it's the regular radical except with a little 3 at the front end. So that is the notification that you want to find the cube root, not just the square root. All right, so definitely pause here, get everything copied so that you have the information. Okay, so let's take a look at a couple examples. Find the cube roots. So for number 1, example 1, we have the cube root of 8. Now you may know some cube roots by heart. Again, we're looking for number times itself to equal 8. Now, if you know it by heart, that's fine, but I want you to go through this process with me of what do we do if I don't know? What happens if I have no idea if this is a perfect cube or not? Okay. What we're going to do is we're actually going to reach back into our memories to 6th and 7th grade and remember factor trees. Okay, so what we do here is I'm going to think of 2 numbers that multiply to make 8. Okay, so stick with me. We're not cube rooting quite yet. All I'm doing right now is figuring out 2 numbers that multiply to equal 8. Well, 2 times 4. And what I'm going to do is I'm going to continue finding factors until I get prime numbers. And I just brought this first 2 down, and 4 multiplies to 2 times 2 times 2. Do you see how if it's a number times itself, since this is 2 to the third power, it's essentially what I have here. If I multiply 2 by itself 3 times, that's 2 to the third power. So I essentially have 2 to the third power here if I were to rewrite that. If I cube root a cubed number, I actually end up with the base number. Just like, and don't write this down, but if I were to, if you looked at the square root of 4, you would tell me it was 2. Well, if I rewrote 4 as a squared number, 4 and 2 squared are the exact same thing, just look different. My answer would still be 2. So if you square root a squared number, you get the base number as your answer. If you cube root a cubed number, you get the base as your answer. Let's look at another one. Cube root of 64. We'll start with 2 times 32. Easy enough. And I'm going to continue until I find all the prime factors. 2 times 16, 4 times 4, 2 times 2 times 2 times 2. Bring this 2 down and bring this 2 down. Okay, now I'm not necessarily looking for all the prime numbers as my final answer. I'm looking for something times itself 3 times. Take a look for a second at what I have here. Do you see how I have 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4? See how I have 4 multiplied by itself 3 times? That's 4 to the third power. Let me rewrite my answers up top. If I cube root 4 to the third power, I get 4. So the cube root of 64 is 4. Now let's say that just confused you, what I just did in the blue. Okay, let's say you're looking at me, or you're looking at the video thinking that I'm nuts. Let's back this up just a little bit. I'm going to show you just a little bit differently. I'm just going to rewrite my 2's. Let's just go with this, and let's take a look at our 2. So let's say you tell me, when Miss Ann's alone, there's 2 times 2 times 2. So that would be 2 to the third power, cube rooted. That sounds good to me. Then I have another set, 2 times 2 times 2. That could be rewritten as 2 to the third. So again, all I'm doing is I'm rewriting 64. Instead of using the number 64, I'm rewriting it as 2 to the third power, 2 to the third power. Okay, so the value is still exactly the same. I didn't change the value of anything. I'm just changing the way it looks to help us manipulate this situation, this problem. Now, if I kept 2 to the third power cubed here times 2 to the third power cubed, if I cube root a cube, I get the base number. So this piece is going to give me 2, and this piece is going to give me 2. What's 2 times 2? 4. I still end up with the same exact answer. So however you want to look at this type of problem is up to you. Okay, to be quite honest, I would suggest that you memorize the cube roots up through probably 5 or 6, to be honest. But if you don't have them memorized or you struggle, this is a good way to figure out cube roots. All right, let's take a look at the last one here. Negative 125. Now up to this point, negatives were not okay. However, make yourself a note. Negatives are okay. And here's why. A negative times a positive equals a negative, right? Problem is, these aren't going to give us the same numbers. Let me back up. Don't write this down. If I have negative 1 times negative 1 times negative 1, this is a number times itself, correct? Yes, this is the same number multiplied 3 times. If I were to actually multiply these first two, I get positive 1 times negative 1. Positive 1 times negative 1 is negative 1. Because we have an odd number of things being multiplied by themselves, negatives are now okay. So just know that. The other thing is, you're going to now know that our answer will be negative. So from that point, you can go ahead and if the negative makes you nervous, just ignore the negative for a little bit. Just make a notation that your answer will be negative. Let's take a look. Let's back up a little bit here. All right, so we'll start our prime factorization. I'm going to include negatives just so that you see the process. My number ends in 5, so I'm going to use a negative 5. Negative 5 times 25. Okay, now I have a negative times a positive. That equals negative 125, so I'm okay. Now negative 5 is prime, so I'm going to break 25 down into 5 times 5. Now here's a problem. I need a number times itself times itself. These are not the same numbers. 5 and negative 5 are not the same. However, if I make these two 5's negative, is negative 5 times negative 5 positive 25? Why, yes, it is. So what I've come up with here is a set of 3 negative 5's. So if I were to rewrite that, it would be negative 5 to the third power. Cube root a third power, and you end up with the base number. So my answer to the cube root of negative 125 would be negative 5. Okay? Now, if you would rather, if those negatives inside the problem made you nervous, pause here and get this copied if you need it. I'm going to erase it. Let's say that you wanted to ignore that negative sign for a little bit. Let's say you wanted to find the cube root of 125. That's fine. 5 times 25. 5 times 5. So I have 3 5s multiplied by themselves. So this really is the cube root of 5 to the third power. Cube root, a cube number, and you get that base number. The only thing is I have a negative 125, so that I know instead of positive 5, my answer is going to be negative 5. So you can ignore that negative sign during the process and then come back to it, and that's not a big deal.